Okay, here's a brief recording of the final installment of the lectures on Factorial ANOVA. These are the learning objectives. We'll talk about effect sizes in this one, specifically a measure of effect size called eta squared. Got a new Greek letter here, eta. For Factorial ANOVA, it should be able to calculate, which is a very simple calculation, and interpret that. And then we'll talk about APA formatted results sections, which mostly is review, but we'll talk about them specifically for factorial designs, and then also APA formatted figures. Talk about some more specifics for how to format figures according to APA style. So first, eta squared. There are a couple of ways that you can indicate effect sizes for Factorial ANOVA. There's these correlational measures, eta squared. There's also omega squared, which we probably won't get into. And then those are correlational measures. And then there's also things like Cohen's d, which describe more like differences in means according to the number of standard deviations that two means differ from each other. Eta squared is part of this R family, or correlational family, of effect size measures. And the definition should look somewhat familiar. You can see how it's related to R and R squared. This provides an estimate of the percent of the overall variability in the data that's accounted for by differences in a particular independent variable for a main effect, or the interaction between independent variables for an interaction. So the way this is calculated is quite simple, and I'm kind of showing what this looks like in Excel, which there's a YouTube video that the link is linked here that shows you how to walks you through the process of doing it in Excel. These are the formulas which are on your help doc. For a main effect, it's just the sum of squares, the SS for a main effect, for the particular main effect that you're interested in, divided by the sum of squares total, the total sum of squares. And then for an interaction, it's just the SS for the interaction divided by the SS total. Okay, so if you're looking at the main effect of age, this is what it would look like in Excel. This divided by that, and I believe that comes out to be 0.9 for this particular data, for these data here. So what that would mean is that this is age. So this is the eta squared for the main effect of age. So this indicates that the percent of overall variability in the data that's accounted for by differences in age is about 9%. This 0.35 is difficulty. This is a fictitious experiment that I reference in another video as well. So about 35% is accounted for by differences in difficulty level. That's the other independent variable. And then about 9% is accounted for by the interaction between these two. Okay? Oh, sorry. This one I think is not 9, but comes out to be about 5.5%, I think. Okay, transitioning to APA formatting for Factorial ANOVA specifically. Again, active voice is preferred. You can see some examples. This is an example of active voice versus passive voice, like a one-way ANOVA test was conducted. Instead, you'd say, I conducted a Factorial ANOVA test. You'll need to report F statistics for main effects and interactions, especially the interaction. I usually see main effects reported too. Often that's kind of just a control that your particular experiment is behaving as you expect it to. And should indicate effect sizes, which in our case we'll use eta squared. And here's an example if I look at these results again. So I conducted a two-way Factorial ANOVA determine, sorry for the typo, to determine whether age interacted significantly with difficulty. This test revealed a significant interaction between these two variables. Notice italicized F and italicized P. These are the degrees of freedom, which I pulled from here, this cell right here, and the degrees of freedom for within groups, or the error, for the mean square error. And then you want some interpretation, and suggesting that enjoyment ratings vary differently across difficulty levels in older versus younger participants. Main effects of age and difficulty, you can see here main effect of age and just 1 degree of freedom, and then still the 60. And I've got the eta squareds for those as well. Since this one, main effect of difficulty has a p-value far less than 0.001, we just, instead of reporting the exact p-value, we just say p less than 0.001. Okay, so that's an example of what you would write up for a result. Now the figure, figures of this, and there's lots of different figures that can show up in APA formatted papers. This will be like experimental data. A factorial design you'll often see depicted still in a bar chart. However, this is a little bit fancier of a bar chart than we've made before. So I made another little YouTube video for how to make bar charts like this with the columns kind of clustered together. The error bars are typical as well. This right here in the blue box, this is your legend. There may be ways that you can structure a bar chart where you don't need a legend. If you have enough of the labels under the bars, then maybe it would be fine. But I think it's better in this case to have a legend because it prevents you from having to write high difficulty twice. Here you just have to write it once. Same with moderate and low. This down here is your caption. So you can see there's no title here up on the top of the chart as you're accustomed to seeing. This is really kind of your title, average self-reported enjoyment levels for older and younger participants across 3 levels of game difficulty. And then you'll want some additional info so that the figure can stand on its own. So I add enjoyment was reported on a scale from 1 to 10, and then you'll for sure want to indicate error bars, indicate standard errors. Including this sentence on enjoyment was reported on a scale from 1 to 10 may not be necessary if that's detailed in the text sufficiently, but I think that would be a good thing to have in this case, and when you're reported on this assignment, or things along those lines for like what is this data, what's kind of the range of values, what is it taken from. Okay, all right.